Okay, so you have one of the FluorCam, that means fluorescence imaging device in your lab. We have different lines. We have these devices from the very detailed scale microscopy. It's also this is a FluorCam microscope. Then we have something that is very portable, handy FluorCam. This is FluorCam 800, one of the line of the products from this line you have. You have a closed FluorCam. And at the moment, we have a very new release, FluorCam line, FluorCam 1300. That is a flat panel. You can see the difference between FluorCam 800 and FluorCam 1300. In principle, from the microscopy to the FluorCam 1300, that is mostly installed for plant phenotypic systems, there is a difference in field of view and imaging details. So this is something like an overview of the FluorCam. The FluorCam 800 is a PAM imaging device. So imaging is a very practical tool in research and in laboratory technique, because you can study heterogeneity, you can see the image. So we don't measure just one point, you measure a lot of points, a lot of pixels in the image, and you can see heterogeneity at the same time or in during some development. FluorCam 800, which you have, has imaging area 10 times 10 centimeters. So it's intended for small samples like Arabidopsis plants. You can have it in pots or on plates. Then this imaging area is dedicated also to detached leaves or lichens, mosses, algal colonies. You can see the whole Petri plates, even the square ones. They are approximately 11 times 11 centimeters, as well as microplates. It's a benchtop device, so it was developed for a laboratory use primarily. The big advantage of this FluorCam is its light-proof chassis. So very often during the chlorophyll fluorescence measurement, you need to diag adapt. That is very easy in closed FluorCam 800. You just close the door. In FluorCam 800, you have your imaging area is on the most top shelf. So if you have taller plants or plants in pots, you can position it a little bit to a little bit lower shelf as you see it on the image. So there is some adjustable shelving system, and it's FluorCam 800 close is done for plants approximately up to 20 centimeters. I don't know how exactly looks your seagrass samples, but we can come to that later, how to manipulate with that. Another relative from this family is GFP FluorCam. There is just optically made for chlorophyll fluorescence as well as GFP imaging. As you can see, FluorCam is a quite big family of the devices in PSI, and they can have different features. So, of course, closed FluorCam doesn't have GFP imaging, but potentially it can be equipped with NDVI panel, or it can measure OGIP, QA oxidation. These are different accessory modules that you don't have at the moment, but that can be done. Multicolor fluorescence, it's a UV induced autofluorescence of plant. But what is possible with your device, it's a software module called Multiple Experiment. It's a software module that allows a user to measure repeatedly the same sample. For example, you would like to measure during a day some circadian behavior, or you would like to measure kinetics of the development of some treatment reaction to, I don't know, herbicides or heavy metals. So you can do it with this software module, multiple experiments that can be just activated. This is a technical specification of your FluorCam. So the FluorCam, of course, is for measuring of fluorescence parameters. It can provide you different protocols and really a lot of parameters, more than 50, in a protocol called quenching analysis. I would like to divide these parameters to something like absolute or measured parameters. These are parameters called F0, Fm, Fv, or Ft. These parameters are actually the images you measure in reality. And from this, by mathematical combination of 2 or more images, you can calculate so-called calculated parameters. Well-known calculated parameter is Fv over Fm, or maximum quantum yield of photosynthesis. Then Fv over Fm prime, that is effective quantum yield. They can have different names like VPS2 or non-photochemical quenching, and so on, so on. So there exists definition of something like 50 parameters. And FluorCam is a quite versatile device that can even allow you to define your own parameters with a little help. Of course, it's not for everybody, but there is a configuration file where you can even define your own parameters, or we can add some new parameters. This is a camera-based device. The camera that is in your FluorCam is a CCD camera. That is quite sensitive and has also nice resolution. So this camera is ideal for weak signals like chlorophyll fluorescence, or it can operate in the mode of long integration that is mostly used for fluorescence proteins and other fluorophores. Resolution of the camera is 1360 times 1024. If you have samples, they are very weak in signal. We can use a function of the camera called binning, that is in technical terms, something that is very well known. You simply count together pixels 2 times 2. So of course you decrease resolution from the original full resolution to 680 times 512 pixels, but you increase the signal 4 times. So this is a kind of trick that can be used for very, very low signals eventually, but I haven't used it for a few years. The camera is quite fast. It can take 20 images per second. I already mentioned it can operate in video mode. This is a mode that you will use mostly, but it can be switched to another mode that is called snapshot. This is a mode that we use for long integration times. AD converter is 16 bits. So the signal that you measure from camera, it's from range between 0 and approximately 60,000, the gray levels. And detector is sensitive in the whole visible spectrum. This CCD chip is silicon, so it's sensitive up to 1000 nanometers. The light that you have in your system, do you have a question?
Yes, there's one question here.
Okay, sorry, I switched to the regime where I don't see you.
What's that guy here?
Can you hear me?
Yes.
You mentioned about the range of wavelengths. Is it like hyperspectral?
No. It's just this is a technical specification of the chip. So in your device there is a chlorophyll filter that maximum of the that measures the emission band between 690 to 770. This is our optimized filter for chlorophyll fluorescence, but eventually we use the same camera also for bacterial chlorophylls, just using different filters, shifted more to 780, 800. It's not a hyperspec, it's just a sensitivity of the camera. You can use it with different filters. So the same camera we can use with GFP filters that is in green, 500, 510 nanometers. Here we have chlorophyll filter. You don't have filter wheel where you can change the filters, and you can use it up to 1000 with different filters.
Yeah.
Okay. The LEDs you have in your system, you have two colors. One color is red-orange. Approximately the peak wavelength of these LEDs is 620 nanometers. These LEDs provide measuring pulses and actinic one. I will explain later. This is actinic that is called actinic 1, and it's a weak actinic light. The maximum of this actinic light is 300 micromoles per square meter per second. Another color of LEDs, second pair of LED panels provide white illumination. There are cool white LEDs, 5700 kelvins, and these are providing strong light, so they are dedicated for saturating pulse. In your device, the saturating pulse is approximately 4000 micromoles per square meter per second. Exactly, it's 4020. So we always have a calibration of your light. We have calibration files, and you should also have these graphs in your documentation folder. So saturating light is 4000, and this white light can be used also as actinic light. Saturating pulse is restricted for short time, not to overheat the LED panels, but the actinic light that gives in your device more than 2000 micromoles can be used for seconds, minutes as an actinic light, so very strong light. This is a very typical combination of light, and we can get even more intensity from the LED panels. For example, from actinic 1, we can get more, but this is a setting that we have to provide customers. Actinic 1 is for low light application, where you need to tune low light intensities like 10 micromoles, 20 micromoles for sensitive samples like algae, mosses. And the cool LED and actinic 2 is used more for plants. So this FluorCam is designed to be versatile for different organisms. Okay, here are some other specifications. Camera is communicating by Ethernet. You already saw the cable at the rear side. Here is some outer dimension. The FluorCam weighs approximately 40 kilograms. Even I can carry it for a short time, and I can manipulate with that. And here is some electrical specification of the device. So as I know, you already unpacked the device and assembled it, or you assembled it before. Assembly is very, very easy. You just need to connect the power cable, everything on the rear side. And you just need to connect communication Ethernet cable for the camera. FluorCam 800 close is something like, let's say, coffee maker for operation. Of course, it's not so easy to operate it then and to preset the protocols, but we try to make it as a coffee maker, at least for some kind of easy manipulation for customers. The hardware that you have, I already mentioned that you have two pairs of LED panels inside. If you open the front doors of your FluorCam and you put your head inside, you will see panels from the side, from left and right. This is the first pair of panels, and another are oriented in perpendicular position. So the orange panels, they give actinic 1 and measuring pulses, the weak light, and the white. Here is a blue or it's in the picture. It's more artistic. Here's a combination either with blue LEDs or it's a kind of photograph is blue. But these are the same LEDs. We have them in different colors, either blue or white, and they provide saturating light and strong actinic 2 light. In the middle, maybe you see in the top something blacky. That is a camera with a lens. The lens see 10 times 10 centimeters. There are some knobs on the lens. We try to fix them for the customers because there is a shutter and aperture. So if you try to manipulate and to move these knobs, you can close the shutter or close the aperture. So be careful. If something like that happens and suddenly you don't have signal in your device, or you don't have signal that you are used to, then contact us, or maybe somebody was playing with these knobs. Even they are glued, but you cannot glue it perfectly, so nobody can move it. Here is a schematic representation of what you saw in the photograph. This is an older picture, so there was also the power supply that is now installed inside the case, or this is a general pixel for all FluorCams. Control unit is also at the moment installed inside, and there is also some display where you can see if the device is on or off, or even if you change the filters, if your device contains filters. Here you graphically see how the panels are oriented from the side. So this is our older line of the system. Side panels, they have advantage and disadvantage. One advantage is that if you have illumination from the side, like here under angle approximately 45 degrees, then you have less effects like full reflection into the camera. Disadvantage is that this illumination is really optimized for certain layer. If you imagine the beams going from the side, so they simply cross in certain plane at certain distance from the camera. And this is our working distance that is approximately corresponds with the first shelf of your first shelf in your FluorCam. And the beams upper and below this position, they are not so homogeneous. So it's strongly recommended always position your sample the way that your imaging area is approximately at this distance and at the fixed distance. If you one example, if you have, for example, Arabidopsis in different pots, then if you have taller pots, please go down with a shelf to have your rosette in approximately same distance from the camera. Of course, there is some working distance, so the camera is focused and can see it even if it's a little bit further. Okay, so here are some more FluorCams, some of them the older lines. Some of them even on the down image, you can see it installed in growth chambers or on the vehicles. A rover FluorCam that is designed for field experiments. Do you have any questions regarding hardware?
Yeah, I think they're all good, Zuzana. You can go to the next part.
What can I make?
Just one thing I want to mention here. I forgot to introduce Maddie. Actually, she's also with us today. She is our volunteer or a trainee student with us running this FluorCam. And she's from UK.
Okay, nice to meet you. Okay, so let's change a presentation.
Check. Do you know
give me a second. I am switching between.
This one, it's supposed to slot in. Was it somewhere else?
I'll just check.
Yeah. I'm just checking for the shelf, Zuzana. I didn't realize the
Exactly.
shelf.
You can take the shelf out.
Yeah,
completely.
but there's no shelf. There's no shelf in the moment.
Okay.
I was assuming it was
One more thing with a closed FluorCam, as it is just a simple box, it can be even rotated up down. This is, if you have microscope, you have upright microscope and inverted microscope. So your camera is from the down. And for this measurement, this is a fantastic measurement if you are working with some suspension samples like algae in microplates, because very practical. if you put something in the microplate, some algae, they can sediment. So of course, if you measure from the top, first of all, there is reflection from the water level. But if you measure from the down, there is a microplate. You need special microplates with an optical bottom. But there is a microplate, optical bottom, and immediately it's together with the water. So there is
We can do
and
without.
if the sample is
Yeah, I'll just give a
sedimenting,
shake
you
down.
can nicely measure it from beneath. For that, you need either a glass shelf that can be made on place, or or we have in our offer also the shelves with a hole for microplate.